welcome to the fourth in our series of short interviews on the topics of artificial intelligence and agency. In the interest of our guests and audience time, these interviews will be brief, but each is supplemented with a reading list that allows for exploration of these topics in greater depth. And our guest today is Professor Anil Seth. Professor Seth is a British neuroscientist and an academic at the University of Sussex, and is amongst the most cited scholars globally on the topics of neuroscience and cognitive science. His significant contributions include an important book such as Being You, A New Science of Consciousness. He also edited important volumes such as Modeling Natural Action Selection, and has edited important journals such as founded and edited important journals such as Neuroscience of Consciousness. Professor Seth, thank you very much for accepting our invitation.
Majid, thank you very much. That's very kind of you. Happy to be here.
All right, so I'm going to start by asking a general question about the relation between intelligence and consciousness and agency. So you have had made differences between intelligence and consciousness. Could you briefly elaborate on that, and also explain in what sense agency might be related to intelligence and consciousness or different from them?
Sure, I'll try. I mean, I think I have the feeling anyway that there are three different concepts that have relations, but I think we tend to overestimate their interdependency, partly because of our anthropocentric perspective, which is to say, we often take the human example as definitional of how things have to be, rather than as one example of how things might be but could be otherwise. So that's a bit opaque. I mean, let's start with consciousness. That's my primary interest. And of course, there's no single agreed on definition, but I think a good definition, working definition for me, comes from Thomas Nagel, who said that an organism has conscious mental states if and only if there's something it's like to be that organism. And this is a useful working definition. It sounds maybe a little circular, but what it's pointing to is that the fundamental definitional property of consciousness is the presence of any kind of experience whatsoever. As Nagel kind of suggests, it feels like something to be me, to be you, to be any kind of conscious thing. Doesn't necessarily have to be accompanied by any great degree of cognitive sophistication. It's just consciousness is about being and feeling primarily. Intelligence, on the other hand, is more about doing rather than feeling or being. Again, there's no single consensus definition, but doing the right thing at the right time, solving problems flexibly, all of these things are aspects of intelligence. And that manifests in things like linguistic intelligence is a particular form of intelligence, and so on. So I think that they're really quite different and possibly completely orthogonal, although it may not be completely independent. You might need some amount of intelligence to be conscious in practice. There may be certain forms of consciousness that require certain forms of intelligence, but the basic concept is still very distinct. Agency is distinct again, and I think this is interesting. It's something I know actually less about than I think the other two, so I'm interested to talk about it with you on this podcast. But agency to me has connotations of, there needs to be an agent, which is a sort of bounded system that is in control of its actions to some extent. And this, again, I think can operate at multiple levels. Systems can make actions according to objectives that they have or that they are given. And here I think we have very interesting issues, especially in artificial intelligence. AI, we have systems which are intelligent in some way, if not necessarily in the same way that we are. And increasingly people talk about AI agents too, as AI systems that act in the world. But that seems to me a very thin form of agency so far. They're acting on goals given to them. biological systems have a deeper, thicker sense of agency. I think that's bound up in the sort of the biological imperative to stay alive, to keep on living, and perhaps to some extent with consciousness too. There might be certain forms of agency which require a goal to be a kind of conscious goal, for that to be described as a goal truly pertaining to an organism.
Well, very well. Thank you very much. This was precisely what I wanted to ask. When you, in specifying consciousness, you didn't just mention having experiences, but when referring to Nagel, but organisms having experiences. So there is something specifically biological about consciousness. I gather you take about consciousness when you were starting to talk about agency. You mentioned bonded systems rather than biological systems directly. So, uh, but then, of course, you said that there could be thin forms of agency and thick forms of agency. Could you elaborate a bit about what you think about the biological substrate of consciousness? And then I'm going to direct that to question about the biological compartment or counterpart or agency.
Sure. I think the idea that consciousness is a specifically biological property, I think that stands still as a hypothesis, or maybe even weaker than a hypothesis, more like a sort of a philosophical proposition that's not yet fully testable. But it is a position that I find in my work quite compelling, partly because of the contrast it raises with a fairly dominant perspective, which is that consciousness is some form of information processing or computation. And this assumption, broadly known as computational functionalism, has been pretty dominant. And that assumption says that it's not the stuff that matters. Carbon is just one way of implementing computations, and silicon could be just as good if you know what the right computations are. So there's been this, I think, extensive, well, not I think, there has been an extensive discussion about whether AI can be conscious. And part of that discussion, I think, is motivated by a confusion between intelligence and consciousness, something which can be resolved simply by appreciating the distinction we started with. So just being intelligent itself is no guarantee that consciousness will come along for the ride. But then underneath that, there's still the idea that if you have the right kind of computations, then you have consciousness, even in a silicon system. Many theories of consciousness that we have, like global workspace theory or higher order thought theory, these are some of the popular neuroscientific theories. They at least strongly imply that an AI system that had the right kind of internal architecture would also be conscious. And I kind of push back on that, because I think there are many reasons why I think it's wrong to sort of elevate computation as the level of description that matters. It matters for intelligence because you can define intelligence in terms of doing, as we started with, in terms of transforming an input into an output. So it's fairly obvious that some kind of computation or some kind of algorithm will be up to the job, because that's what algorithms do. They transform inputs into outputs. But consciousness being about being and feeling, it's just not obvious that algorithms will be sufficient. And the closer you look at the brain, the more you realize that the idea that the brain is some kind of meat-based computer is just a metaphor. It's a powerful metaphor, and it's given us a lot of progress, but it's still a metaphor. And I think one important difference is there's no sharp distinction in brains between what you might call the mindware and the wetware, between the hardware and the software. And if you just range together observations like this, it becomes very difficult to think that the biology of the brain is simply there to implement various computations. There are tons of other things that brains do that are non-computational. They don't sort of implement Turing algorithms, mapping one set of numbers to another. There are electric fields, there's metabolism, there's functions that include aspects of the material itself. I mean, metabolism is one of them. It's specifically dependent on biochemical processes, specifically dependent on parts of what the brain is made out of. So all of this together leads me to the view that consciousness might be very intimately related to our nature as living creatures, grounded in things like metabolism. And another concept we'll probably talk about, autopoiesis, this property of living systems that they recreate their own material basis, rather than in the level of substrates independent algorithms. But nobody knows. I mean, it's like you have to have a bit of humility as well. I mean, just as you can't prove that computations are enough, you also can't prove or test at this point that it's life that matters. But it seems it should be taken pretty seriously, because all the examples of conscious systems that people agree on are living systems. So is this just a contingent fact, or is it something we should try to understand? Well, which aspects of living systems matters? Is it something other than just the computations they implement? And I think it might be.
All right, I see the reason for computation, for skepticism about computational functionalism, and also how your suggestion is a reaction to some other views which take the integration of information or some other computational factors as. But when we think of these biological processes such as autopoiesis, homeostasis, and so on, sometimes it seems that they too could, I mean, the way that you set some sort of contrast between computational mechanisms and on the one hand, and metabolic processes on the other hand, uh, uh, what makes me to try to press this a bit further is that sometimes these metabolic processes too could be modeled or at least represented in computational terms, such as you very well know and presented in your works, predictive processing and free energy principle, which seem to be some sort of also specify life as well as consciousness in terms of some sort of internal architecture or information processing in a specific sort of systems. And I understand that this free energy principle and predictive processing could be implemented in biological systems. They have been developed for particular biological systems, but they also could be implemented in other sorts of physical systems. So what is it that makes this biological specifically?
It's a very good question. I mean, to the first part, of course, you can model, simulate any kind of physical process computationally. I mean, that's one of the great functional powers that computers give us. But when you simulate something, you do not in general instantiate that thing. And that's very clear to us in other contexts. When we simulate a weather system, we don't expect it to instantiate rain and wind. When we simulate a black hole, we don't expect it to instantiate gravitational collapse of the solar system. We know those are just simulations. And so the question is, what's the relationship when we have a computational model, let's say, of predictive processing or the free energy principle? Is it something that's instantiating this process, or is it a simulation of? And I think it's kind of a complicated question, but we can be, I think it's complicated because predictive processing does serve as a computational algorithm, right? And we see this in AI too. We see this with generative AI, which is using some of the components of the theory of predictive processing, for instance. And we see it with machine learning, neural network machine learning in general. Like algorithms that model aspects of brain function are very powerful. They actually do things. In the predictive processing thing, they serve as approximations to Bayesian inference. Now, this, I think, to me, this gives me encouragement that theories like predictive processing, active inference, which see the brain as some kind of prediction machine, are on the right track. They're picking on something that's actually a very useful thing for the brain to be doing. But this does not mean that the brain does this in a computational way, right? It means, so the free energy principle is not at heart a theory about information processing or computation. it's more of a dynamical theory. There's this continuous minimization of a quantity called free energy. Now, you can approximate that with a predictive processing algorithm, turn it into a computational method and algorithm, and it does useful stuff. But it doesn't mean that that's the way the brain is doing it. And actually, it's not only that the free energy principle is a continuous process of minimizing a quantity of it's that it's fundamentally grounded in something like autopoiesis. That at the kind of the most basal level of the free energy principle, there's this idea of systems that have to minimize the states, the surprise of the possible states they could be in. They have to minimize the entropy, let's say. And this is where, to be honest, I still think it's a little unclear. But there are some very suggestive links between the sort of the minimization of some kind of informational free energy, which underlies predictive processing, and a minimization of some more thermodynamic kind of free energy, which is related to metabolism and autopoiesis. But at least it's plausible to me that there's kind of a smooth continuum between prediction error minimization in cortical circuit thawing perceptual inference and some much more substrate dependent kind of free energy minimization at the level of autopoiesis and metabolism. Of course, you can model all of this computationally. That's fine. But that by itself doesn't really tell you anything about whether computation is sufficient to instantiate something like consciousness, which is not self-evidently algorithmic.
Oh, yeah, very well. I take the point very well. And I also guess that your reference to subtle links speaks to things such as Landauer's principle, formal ways of linking them together. So, and I completely understand that the brain doesn't need to be computational. But my question was rather that so far as we can use this kind of internal architectures to provide high fidelity simulations of some cognitive processes and consciousness, would it matter whether it is really instantiated in biological systems or not?
I think it matters a great deal. I mean, you could say it's the most important aspect, and it's where I think most of our kind of epistemic danger lies. It does depend a little bit on how you ground your morals and ethics, but I think there are many good cases to say that whether something is actually conscious or not really does matter. Now, there's ways to challenge that. You could say, well, you could take a more Wittgensteinian point of view, like my friend Murray Shanahan does, and say, well, it's kind of a mistake to talk about there being a fact of the matter about consciousness. Or you could ground ethics in other things, perhaps agency, perhaps simply complexity. But still, I tend to be, perhaps just through academic taste, a phenomenal realist. I do think there's a fact of the matter about whether some things are conscious and other things are not. And I think that difference makes a difference ethically and morally. And this is where it gets tricky, because we are already in a situation with AI where many people are quite convinced that they are dealing with systems that are not merely intelligent in some way, but also conscious. And if they believe that, well, if they're right, I mean, if something is conscious, then it deserves moral consideration. We have to take its interest into account. That's one aspect of the moral perspective on this. The other aspect is if it seems conscious to us, if we have a detailed computational simulation of something, whether it's based on free energy or transformers and language models and so on, if it seems conscious to us, then we are in a tricky position, because if we don't know what the fact of the matter is, then we might decide to treat it as if it were conscious according to the precautionary principle and sort of waste some of our moral resources where they're not needed. And of course, it can affect our own minds. If we think we're interacting with a conscious system, we can be more vulnerable, or we can have our minds slightly brutalized, to go back to Kant, if we treat systems that seem conscious as if they're not. So yes, I do think it matters greatly what the fact of the matter is.
Very well. So I just could resist getting attracted to this discussion, but now stop my getting digressed and return. I mean, go to the topic of agency.
Yeah.
So the connection between agency and consciousness. So if we don't want to pursue that at the level at the level of our experiences, at the level of anthropocentric level. Do you think that biologically, at the level of underpinning mechanisms, the relation between consciousness and agency could be specified? I
You
mean, the
know,
relation or the difference?
sorry, I mean, it's something I think needs, to me anyway, I need to pay more attention to this. There's something, a question that arises for me here is whether agency is necessary for consciousness in general. It's clearly not necessary for every conscious experience, right? I can have plenty of conscious experiences which don't involve agency. Agency is a specific form of conscious experience. It's something we feel. At that level of description, there's a phenomenality to agency. But as a biological system, I think any evolved biological system has built into it something that looks a bit like agency. All evolved systems act in the world, and they act in some way in order to enhance their survival prospects. That's what organisms do at some level and in some way. So from that perspective, there's a sort of necessary presence of some amount of agency, basically any biological system, whether it's a bacteria or an orangutan. Now, whether this is a necessary for consciousness in general, it seems much less clear to me. So it strikes me that, so for instance, a scenario where you might have consciousness but no agency might be in something like a cerebral organoid, something like that, or maybe not a current one, but maybe along that trajectory of technological development. Cerebral organoids are these kinds of brain-like structures grown in dishes made out of human neurons, usually from stem cells. So one whole kind of uncertainty goes away. They're made out of the same stuff. They are semi-living systems, even if they're not organisms. They're made out of cells. They're made out of the components of life. But there's very little reason to think they have agency. Now they might. Mike Levin has done amazing work with sort of xenobots and anthrobots and sort of looking seeing agency baked right into the individual cells even. But I think that's an open question. At least conceptually, to me, it seems possible that you could have conscious experiences without any kind of agency. Yoshua Bengio talks about this in AI, I think quite nicely, even though I'm very skeptical about AI being conscious. When he's thinking about the kinds of AI that we might want, he talks about AI systems as desirable AI systems in terms of oracles, things that are very wise, but actually have no interests, goals, or agency of their own.
Very well. Just to be clear about the significance of biological aspects, and also because you refer to xenobots and Levin's work. So this kind of goal-directedness that brings up some sort of agency, at least in works of Levin, it seems to be very general. So far as they aim to, again, it goes back to predictive processing somehow, to organize themselves in a way that contributes to the minimization of their free energy or something. I mean, it would be their common goal. And in this respect, many biological systems and perhaps also some non-biological systems could possess some sort of agency. But to relate that to what you said earlier about morality and ethics, I presume that is there any stronger link between more sophisticated forms of agency and biological processes in some more sophisticated organisms?
I think that's quite likely. To my mind, it's still a bit of an open question, but you can see a kind of one of the gradients along which you can see a dimension, if you like, of agency that you can see varying is the extent to which you say the agency or the like if we think of agency for now as just a system having goals and making actions towards the fulfillment of those goals, exhibiting some goal directedness. So one dimension along which you can vary that kind of agency is how the extent to which the goals are the intrinsic to the agent, to the system, or endowed to that agent, given to that agent by an external agent, another agent. And in biology, most of the time, we're at one extreme of that dimension, where the goals are intrinsic to the organism. Now, there may be some sort of weird, interesting exceptions where you have parasites invading wasps and getting them to do other things which are against their own interests. There are all these kind of, biology finds a way. We may even train domestic animals and so on. But broadly speaking, biological systems have a sort of deep intrinsic agency, whereas AI systems so far have goals that are given to them by a user or by the designer of the system. But of course, there's a kind of smooth continuum here, and even in AI systems, as they become more autonomous, as they become smarter, you can have a hierarchy of goals, whereas AI system could figure out what is the right goal for it to have, in some larger context, which still may be extrinsically applied. In my PhD, we used to do this work long ago with evolutionary robotics, using genetic algorithms to evolve control systems for robots in some sort of computational mockery of evolution. And what was interesting there was, we would establish a fitness function, but the fitness function could be very, very vague. It could be something like stay alive, and you'd see these evolved robots develop their own more specific goals in order to fulfill this very vague, larger goal. So I think there is a continuum. And what's an open question to me is, are there any sort of discontinuities in this continuum? For instance, where, whether it's living or non-living, is that a discontinuity? Whether a system is conscious or not, is that a discontinuity? And the answers to those questions, I suspect they are, but I don't know for sure.
All right, very well. Our time is almost up, but I still have two questions that I'm persuaded to ask. One was on the basis of your earlier remark about the possibility of there being organoids that are conscious but not agentic. So wouldn't it be a matter of which marks of consciousness we are going to specify when we want to test whether they are conscious, or whether we are going to, for example, include behavioral and agentic markers in test of consciousness to tie that to consciousness or not? Wouldn't it be to some extent, depending on the way that we design these experiments or tests of or markers of consciousness?
It may be. It's a very, very good question. I think it highlights the fact that we don't have kind of one size fits all markers for consciousness. I was just at a conference a month ago at Duke University, all about tests for consciousness, where we discussed many, many different cases where it's uncertain about whether a system is conscious, ranging from human patients with brain injuries, newborn human infants and fetuses, to non-human animals, to organoids, and to AI systems. And in each case, there are certain tests which may be informative in one context, which are not informative in another. Now, if a human patient with a brain injury starts fluently conversing with you, that's very good evidence that they've regained consciousness. But of course, if a language model does this, it's not really any evidence at all. And agency, again, it's something that has some diagnostic value in a human case, but it gets back to this idea about whether agency is a necessary property of all conscious experience, in which case, yes, it would have diagnostic property if you could figure out how to test for it. But I suspect that it's not a necessary property of consciousness in all cases, and so you might be at the risk of making a false negative if you impose that criterion as part of a test for organoid consciousness. That said, if organoids start to behave in a kind of agential way, and this is also happening a little bit. There are some people who are wiring organoids up to sensors and motors, and again showing that they're quite easy to train in order to do some goal-directed behavior. Does that move the needle? Well, maybe a tiny bit, but not a lot to me.
All right. Thank you very much. And the last question, to make it the old circle, I asked the last question about the first point that you made about going beyond an anthropocentric perspective, right? So, when we speak of some sort of biological realism about consciousness or agency, so it seems that we start from our own case, a specific neurophysiological constitution in our case is connected to the form of consciousness that we experience or form of agency that we have. And it makes it some sort of biological, but by the same token, it makes it human specific. And now if we want to, so sometimes I wonder whether it is some sort of human specific consciousness or agency that is related to these biological factors, or how could it be bootstrapped to other sorts of systems that may demonstrate some sort of consciousness, or how could it be related to consciousness simplicity, if such thing could exist at all? I mean,
yeah, this is really I think the crux of the problem, and we always have to walk the line between using the human case as an example where we know a phenomenon exists, or at least one example of a phenomenon, and we can characterize it because it's present, without being overly restrictive and thinking of the human case as definitional. And I don't think that there's no easy solution to that. I mean, my hope, putting an optimistic hat on, is that there's some kind of iterative, slow generalization becomes possible. I mean, this was the approach about testing for consciousness that Tim Bain and Liad Mudrik and I and others wrote about in a paper last year about tests for consciousness, a kind of iterative natural kinds approach where we treat something like consciousness, but I suppose this could equally apply to agency. Oh, I don't know, actually. I mean, certainly for consciousness, being a phenomenal realist, I like to think of it in terms of natural kinds, but so things that carve nature at its joints, but then also recognizing that the way consciousness manifests in humans is not the way it has to manifest in all cases. And then it's just a really hard job. Like, okay, so what aspect of human consciousness is sort of part of that natural kind, which is a contingent feature of the human case? And already we've done that a little bit, right? I mean, the thing is, it's not hopeless. I think we already make very good inferences about consciousness in mammals and primates, and they're not humans, and many of them don't, most of them don't speak. And that's already, a step, I think, that we've taken with some degree of confidence, because many different kinds of markers line up, and they line up because of some, as yet unsatisfactory, but at least there's some theoretical grounding for why they line up that gets us away from the surface level criteria we might apply, which are things like, oh, do they speak, and so on. So I think there's a method, and I think it's the slow work of iterative generalization, where we keep on searching for deeper the deeper layers of whatever the phenomenon is that we're interested in, whether that's consciousness or intelligence or indeed agency.
Excellent. So thank you very much for this interview. Is there something that you want to add, something that we didn't discuss during the interview, but you think is important and should be noted in this context?
Well, I suppose the only other thing was, I think one of the great provocations of the new technologies that we have, like organoids and AI, is that they're forcing these questions upon us, and they may have previously sort of remained in the realm of philosophical thought experiment or science fiction, but we're really being forced upon. This is both a good thing and a bad thing, right? It's a dangerous thing because there are now real ethical consequences, real societal consequences, but it's a good thing in that they're allowing us to think about these things, I think, in better ways. and just one example to finish. I mean, we've already drawn some possible conceptual distinctions between consciousness, agency, and intelligence. Another feature of the human mind is understanding. And we've often argue whether AI or language models really understand, what they say. And again, you could argue, well, maybe they don't. They're just, on one end, you've got the stochastic parrot view, which I think is unfair. On the other end, you've got, again, you'll have a anthropomorphic projection of, well, it speaks, so it must understand, because when I speak, I understand. But it may be that understanding requires something like embodied interaction with the world. And this is not a new view, right? I mean, people have talked about the symbol grounding issue for decades in philosophy. But again, it points to a fact that you may have a separation of things that is happening in practice that people hadn't thought might be possible. So I, for instance, I'd never particularly thought that, oh, maybe we can separate understanding from consciousness. But I think now we take that possibility very seriously. If we have some future language model that is not only sort of actually interacting with a world, but is trained, from the ground up, the foundation model is trained from the ground up, embodied and embedded, then it might well be justifiable to say that the language model truly understands. But if consciousness turns out to be substrate dependent, it truly understands, but it is still completely not conscious. And that for me was like, oh, I hadn't thought that might be a possibility. And now I think that is a possibility.
Oh, that's very interesting. So I'm going to get a grip on myself and do not ask new questions. I'm thanking you for this excellent interview and thank our audience for watching this. Thank you very much, Professor Seth.
Well, thank you for the conversation too. Thanks very much.